An alpha particle and a proton moving with the same speed enter the same magnetic field region at right angles to the direction of the field as shown in figure. So we have this, okay, figure. So the trajectories followed by the two particles in the region of magnetic field. We need to show the trajectories or path followed by alpha and proton, okay, that is alpha particle and proton in the region of magnetic field, and find the ratio of the radii of the circular paths which the two particle may describe. And we can see magnetic field, okay, is perpendicular to the plane of the board and is directed inward. So we have cross inside the circle. It indicates that magnetic field B is perpendicular inward, okay. So we have this. Now from question, okay, alpha particle and proton have same speed and enter the same magnetic field region at right angle or angles to the direction of the field. So let V be the speed of the proton and alpha particle also have the same speed, okay, that is V. Now we have this, okay, proton entering magnetic field B, which is perpendicular inward, and alpha particle moving with velocity V, okay, and is entering the same magnetic field, okay, region. So what we find? We find, okay, angle between velocity and magnetic field is 90 degree. So I'm writing over here, angle between velocity and magnetic field is 90 degree. So we need to understand this, okay. Now we know this, okay. Charge particle moving in magnetic field, okay. Magnetic field experiences magnetic force and follows circular path. So we know this. And magnetic force, okay, this is given by the expression Fm equals charge Q bracket V cross B. So we can write in this way, magnetic force, this equals Q V B sine 90 degree, and this is 1. So the magnetic force in magnitude is Q V B. So this is the maximum magnetic force, because sine 90 is 1, which is maximum, okay. So this is the magnitude of maximum magnetic force. Now since the charge follows or describes circular path in magnetic field, okay, therefore we can write the magnetic force provides necessary centripetal force. Therefore, we can write, so let us denote centripetal force by this symbol, okay, Fc in magnitude. Therefore, we can write Fm equals Fc. So we have this, okay, Q times V, B equals, and centripetal force equals M V square by R, where R is the radius of the circular path, okay. So we have this M V square by R. So let us simplify this, okay. Therefore, we can write R, which is radius, okay. This is radius of circular path, okay. Therefore, we can write R equals M V by Q times B. So we have this, clear? So we are asked to find the ratio of the radii of the circular paths which the two particles may describe. So we have this. So I'm writing this expression, okay, and this way. Let us call it equation 1. So we have this. Now, let us come to this, okay, note. So I have written the mass of proton, okay, MP, and this equals this value, okay, and mass of alpha particle, M alpha, equals this value, and U is the unified atomic mass unit, and 1 U equals 931.5 mega electron volt. So we have this because we have alpha particle and proton entering with same speed in same magnetic field at right angle to the direction of the field. Now, we have this, okay, R equals mv by qb. So we have this. This is equation 1. Now, let us go back to this slide, okay? Now, we can take mass of proton, okay, approximately 1 U, okay? And mass of alpha particle approximately 4 U, okay? So we have this, okay? Now, for alpha particle, okay? So this is alpha particle. So what we have for alpha particle, okay? Mass of alpha particle is 4U, where U, as I said earlier, is a unified atomic mass unit. And charge of alpha particle, see, we are going to find the ratio of the radii, okay? So we have this expression, clear? And since the speed is same and magnetic field is same, okay? So what we do from this relation, we write R, that is radius, okay? This is proportional to M, that is mass of the particles, divided by the charge of the particles, because V and B are same or they are constant, okay? So I'm writing in this way, they are same. So charge of alpha particle, so this is twice E, okay? So we have this alpha particle. So I can write in this way also, plus 2e. Now, for proton, okay, proton, we have this, okay, mass of proton, as I said earlier, let us take it approximately, okay, we are taking it approximately 1. So I'm writing in this way, okay, this is 1u, and charge of proton, this is plus e. Okay, now what we do, from equation 1, okay, we can write in this way, R equals mv divided by qb. Now, as I said earlier, for velocity, speed and b being same, okay, or constant, we can write R in this way, proportional to m by q. So we have this. Therefore, we can write R for alpha, okay, divided by R, that is radius for proton, equals, we can see R is directly proportional to mass. So we have this mass of alpha by charge of alpha. So for RP, we can write in this way. So we have this, okay. We have this, clear? We find radius is directly proportional to mass and radius is inversely proportional to charge. So we are using this concept, okay. Now what we do, let us simplify this. R alpha by Rp equals, we have m alpha, that is mass of alpha particle is 4u. So let me write in this way, okay. Let us arrange this first. M alpha by mp, qp by q alpha. So this equals 4u by 1u, and charge of proton is E, okay, and charge of alpha particle is twice E. So this cancels out, okay. So we get, on simplification, 2 by 1. Therefore, R alpha is 2 times R P. So we have this, okay, that is radius of circular path of alpha particle is double the radius of proton. Clear? So we have this. Let us see, come back to the question, okay? So the trajectories followed by the two particles in the region of magnetic field. we need to show the trajectory. And as I said earlier, charged particle moving in magnetic field experience magnetic force and follows circular path. So what we find, okay, proton, it follows, okay, it follows circular path. It follows circular path. So we have this clear because we have magnetic field directed inward. So in order to find the direction of magnetic force, okay, we use Fleming's left hand rule. So this is my left hand, okay, this is my left hand, and this is my first finger, okay. So I'm pointing first finger inward to the plane of the board, and this is my central finger, okay, and it is giving me the direction of velocity of proton, okay, and the thumb is pointing in upward direction so that the proton, okay, is deflected upward and describe circular path, okay. In same way, alpha particle, okay, it is positively charged. So alpha particle is positively charged. So for this reason, it also experience upward force, okay, and follows circular path. So we have this. So we have this, okay. Now, next, find the ratio of the radii of the circular paths which the two particles may describe. So the ratio, okay. So the ratio is from this expression, okay. The ratio is R alpha by Rp equals 2 by 1. So this is the required result.